Hi everyone, welcome to St.Joseph's College. This is BHARATHI, Assistant Professor, Department of Computer Science. Today we are going to discuss a concept in operating system called schedulers and queue. This will be very useful for us to understand how the jobs are being assigned to CPU to do their instructions and how they are maintained in the queue. What are the different types of queues? So this is what we are going to discuss in today's class. Come on, straight away we will get into the concepts. Yes. So before getting into these terms, schedulers, queues, let us know the literal meaning of schedule. Schedule means what? One after the other, what has to be done, how it is being organized. That is the meaning of the word scheduling. In the previous videos, right, we have discussed about the how a process being going across the states. What are the states a process is being traveling through. So with that extension, this scheduling is there are process which has to be get into these schedules so that be allotted to the CPU to do their instructions. So what is this scheduling will be doing? Picking the process from the job pool, because there will be so many numbers of jobs will be there and which are said to be ready to be executed, that will be selected and that will be loaded into the memory and sent to this allotted with the CPU to do the execution. So here scheduling is organizing the OS processes and the CPU time by means of picking up the process from the pool of process and letting into the CPU to do the execution. Here I have given you an example here. See, this is a person of assume this is a librarian, okay? So this is said to be a CPU where all the instruction is being coming inside and being processed over here. And see, this person is called as a job or a process, and this person has been called as a job 2 or a process 2. This is job 1 or a process 1. This is job 2 or process 2. So behind we have another person and that person is called job 3 or the process 3. So what happens here? They come into the library, they get their books and they have to scan, get the permission and they have to go out. This is a process for each one is being assigned to. And this CPU will be doing the execution, right? Scanning that book. That is the process. So this process comes in. The CPU will be allotted with that particular time and the librarian will scan the thing and he will be letting outside. Right? So what happens when this particular person is doing this one? The other persons will be waiting in the queue. Right? See, scanning has happened. Done. He is going out. Next person come. He is standing on the way. Queue, job done, going out. Job 3 comes, process is being carried out, instruction carried out and he will go outside. So this is what we call it as a scheduling. So each one will be allotted with a time to the CPU. Their instructions will be executed. After completion, they will be going out. So here why this scheduling is most important? That is most important question. Scheduling is important. If not, there will be a chaos will be happen between the process, right? Who will be coming first, who will be coming next, who will be coming at the last. So that chaos will be happen. So to control that, we need a scheduling. And one more important point is in these multitasking computer systems that we have now, we need systems which can handle those multiple tasking concurrently. So why we need to handle it concurrently in such a way to allot the CPU its time so that it not be overloaded and also it has to be used efficiently. Okay, so this is the main purpose of doing the scheduling. See, I'll give you an example here. Here we have 1, 2, 3 lanes are there. Okay, so in every lane we have cars to be passed. So if we have only one lane but we have so many process meet, what will happen? The time will be taken more. Okay, here multiple tasks can be done concurrently at the same time. So using 3 lanes, the cars can be passed away, the instructions can be carried out efficiently. So like doing this multiple tasking only, we have been using this concept of scheduling in operating system. Okay, so what are all the different types of schedulers? How that scheduling is being done in an operating system? The main task is to select the jobs which to be submitted to the system and to decide which process to be run. As I have told you, we have so many processes are there. We have to select which one is to be ready, and that should be loaded into the memory, and that should be run, that is to be the instruction to be executed. So to do this schedulers, we have three types: long term scheduler, short term scheduler, and medium term or mid term scheduler. So why I am giving you this diagram in every slide means, because this is nothing but the process state diagram. So every process will go through these stages, right? New state, ready state, waiting, running, and terminate state will be there. And here the schedulers we have to understand this diagram. Only when you understand this diagram, relate with this, we can easily able to understand these three terminologies. Now we'll start with long term scheduler. So what do you mean long term scheduler? I'll give you a live example. See, when we get up, take human being as an example. Our memory will be having so many jobs resides inside it, like brushing, bathing, cooking, learning, chatting with friends, chatting, browsing on internet, browsing, sleeping, praying. Okay, it goes on. So many jobs will be there which are in our memory. But when all these things will be activated, whenever these things needs to be, say example in morning what we used to do, morning we used to brush, we used to bath, we used to cook, or we used to pray. Do we used to sleep in the night, in the morning, early morning when we get up, right? So there are some jobs which we will not do in that particular moment of time. Similarly, at that particular moment of time, which all the jobs are set to be ready to be executed, those things will be taken to the next level. So this all things will be there in the new state. You understand? All things will be there in the new state. So a long term schedule, what it does is it determines which programs are admitted to the system for processing. Now at that time in the morning, I want this brushing, I want this bathing, I want this cooking, and I want this spraying. You understand? So these are the four processes that need to be taken from that state, and it has to be put it in the queue so that it can be next sent to the execution phase. You understand? So from these all process, this particular brushing, bathing, cooking and praying will be selected and put it in the queue. Right. So this we call it as what called long term scheduler. So from the job pool, they will be taken and transferred to the ready queue. And this next stage what happens, so these four places are ready for execution. That where comes short term scheduler. This short term scheduler selects a process from the ready queue. What are all there in the ready queue? I have brushing, I have bathing, I have cooking, and I have praying. So out of these four processes, they are in the ready queue. What will be done now? They will be taken and put into the running queue. They will be put it in the running status. And now what happens? The memory will be allocated to do that instruction. But now what? Now you will be getting a question. Which has to be done first? Either praying, either cooking, either bathing or brushing. Which has to be done first? That will be a big question, right? For there comes a concept called CPU scheduler. So this is CPU scheduler algorithms we have, like first in first come out algorithm, round robin algorithm, and we have some preemptive and non-preemptive algorithms are there. Based on that algorithm, the process will be processed and it will be scheduled in such a way. Right, that is a separate topic that we will see in next classes. So that scheduling we call it as CPU scheduler, or we call it as a short-term scheduler. Whatever is ready in the ready state will be taken to the running state to do the processing. So now here comes a question. Which memory will be used? You can ask me, ma'am, what memory? See here, we have a memory in CPU, that's the processor here runs here, and then we have main memory, and then we have secondary memory. When you take the long-term memory, that secondary memory, everything, see whatever I have mentioned over here. So whatever I have mentioned over here, right, brushing, bathing and all those things, they resides in the secondary memory. Here everything resides in the secondary memory. From that secondary memory it will be taken out. When we take a short-term scheduler, everything will be stored where? Everything will be allocated in the from the secondary memory I have taken, that resides in the main memory. So here the main memory is being used, where it holds all the process which are ready for the CPU execution. So from this main memory is nothing but the primary memory, that's the random access memory. So I have loaded this brushing, bathing, cooking and praying in that random access memory. From here only, according to the scheduling algorithm, that will be taken to the CPU for the execution. Alright, very good. So now we move to the next algorithm, and that's called a midterm scheduler, that is swapping. So I have told bathing, brushing, praying and cooking. Right, it has been loaded here. Now it is in ready queue. Out of this ready queue, bathing is the first process which is entering into the CPU. First process entering into the CPU. But what happens here, during bathing there may be some kind of a requirement may be needed for this process P1. For this process P1 there may be some kind of requirement. What kind of requirement? Sometimes the water may not come. So what will happen? This process P1 has to wait. This process P1 has to wait. Okay, so in between time what we will do, he will come out of the memory and he will be doing some other work. So this process will be inactive. This process will be inactive. So it will take some 15 minutes of time. 15 minutes of time cannot be unutilized by the, they can be utilized by the some other process. So what it will be done, the RAM will be temporarily take away the inactive process outside and it will be moved to the secondary disk. As I have told you before, CPU, main memory, secondary memory. Now the ready queue is there, but after entering the CPU, sometimes the particular process may require some kind of input output devices. So what will happen? It will be sent back here. So again bathing will comes here, but this process can take some more time to be executed. So till that time, this process can be shifted to secondary memory. Why it is being shifted? Simply, ideally, I cannot load this bathing process in the main memory. That can be allocated to some other which are need to be done. So it can be free up the space of the RAM space. So as I free up the RAM space, what will happen? The memory will not be overloaded. It can do the processing of the other things easily. So what happens? It will be taken to secondary memory. Whenever it is required, it is taken back to the main memory, put in the ready queue. As I have told you, main memory means what? It is put in the ready queue or a ready state. Ready queue or the ready state. So wings process back into the RAM when they are needed. So after 15 minutes, the water is coming means what will happen? From the secondary memory, it will be brought again to the main memory, to the RAM. So here which memory is being used? Here for active process, main memory will be used, right? RAM. So whenever we have some of inactive process, what will happen? Taken back to the secondary memory. So this we call it as swapping in and swapping out. So this is being done in the schedulers. For swapping out, who has been used? Secondary memory. That's like HDD and some other external drives will be used for the secondary storage, swapping out. So swapping in will be taken back to main memory and they will be put in the ready state. Yes, clear. So these are the three different types of schedulers. So in between, we have noticed a term called queue. So what is that queue? So queue in an operating system which store the process at different stages of execution. We have three different types of queues. What are the different types of queues? Job queue, ready queue and device queue. So how these queues are being utilized over here. So first I move to job queue. So when I take the job pool, right? When I take a job pool, there we have all the resources will be, not resources, sorry, all the process will be stored there. Example, as I told you, right? Brushing will be there, bathing will be there, praying will be there, cooking will be there, chatting will be there, browsing, learning, studying, everything will be there. So from that job pool only I am going to select. So this has been called job queue, which hold all the process of the system. Whereas the next queue we call it as a ready queue, where this ready queue is be having a process which are ready to be executed and which can be loaded into the memory for execution, and that will be there in the ready queue. See here, when this person comes, this person will be waiting in the ready queue, right? So this queue sets up all the process residing in the main memory ready and we waiting to execute. This we call ready queue. So whatever new process is always put in this queue. New process in sense what? I am ready to be executed. Then we put it in the ready queue. Next I move to the third queue called device queue. What do you mean device queue? As I told you, right, during bathing I need water supply may be cut down. So I need water, so I have to wait. So that particular device we call it, that particular moment we call waiting for an IO device. If you take a system oriented device, so I see here I am an employee who is working on a system. I am just giving something to a printer. Okay, right. But in the same office I have so many people sitting around me and they are also accessing the same printer. They are also accessing the same printer. This person has given the first print. This person A has given a print 1. This person has given another print. I am the person C who has also given print. This person has given first, then he has given second, and then I have given. So what will happen? This printer will be shared by all these three processes. So this process C has to wait until the A's request and B's request is being satisfied. Till then what the C has to do? C has to wait for this IO device. It has to wait till the A and B process completed their request. C has to wait in the queue, and that queue we call it as a device queue. So every device in our system, right, they'll be having a device queue. So this happens between which state to which state? So this happens between this running state, and after running state, if any request is needed means they will be put into the waiting state. It will wait until the request is being satisfied. After they receive that request, whatever they requested, right, then they will be moved to the ready state. Clear? Yes. So these are the three different types of schedulers and three different types of queues that are most important in terms of schedulers and queues. See here I have given all the things in short: long-term scheduler, short-term scheduler, mid-term scheduler. So what does, I'll give you a short recap of all the 6 things. Long-term, what will doing? Everything will be there in the job pool. So job pool is nothing but the secondary memory. From the secondary memory, everything has to be taken to the main memory. So that is the working of long-term scheduler. And what is the memory being used? Secondary memory will be taken to the main memory. And then short-term scheduler. Short-term scheduler, what does that? It selects the process from the ready queue. Ready queue, I have the selected process. It will be taken and put it into the CPU and assign the times to be done. So here which is being used? The main memory is being used. Next comes mid-term scheduler. So mid-term scheduler is what? Swapping between the main memory and the secondary memory. Between main memory and the secondary memory, and that is the working of mid-term schedulers. Next queues: job queue, ready queue and device queue. Job queue, what it does? It holds all the process of the system which are waiting to be loaded into the memory. Ready queue means what? I am ready. I need a time from the CPU to be executed. So that is called ready queue. Device queue means what? If any process need an IO device to be available, needs its request, so that queue we call it as a device queue. It is waiting for a input-output devices to be executed. So these are the short recap about all these 3 schedulers and 3 queues. And then here I have given you few questions with respect to the schedulers and queues. We just ask these questions and try to recollect whether you can able to answer these questions, so that we can make confirm you would have understood the concept. I hope you have understand the concepts of schedulers and queues. With this we can move to the next other topics of in the operating system. So thank you so much for the time. Have a nice day.